Hello, welcome back to another video on the changing bases and Rank-Nullity Theorem example set. This one is going to be our last example, and we're going to be working with a homogeneous systems of equation. I mentioned in my lecture before that the Rank-Nullity Theorem has some consequences, and you can see them in systems of equations. And so I talked about like three cases. One where the system is homogeneous, the other is when the system's non-homogeneous, and the last one is when it's a square matrix. And so the homogeneous, or not the homogeneous, the non-homogeneous one should be very simple to do. We'll do it here in the homogeneous system, and you'll see how. And so the homogeneous system is a little bit more tricky because it involves a vector b, and we have to do some things that will check if this system of equation is consistent and it has a solution, or it's inconsistent, it has no solution. And then the last one is a square matrix, which you could say it's a little bit of both of them. It's either or. I'm not really sure. But the square matrix is kind of like a special case because it's a square, and we discussed like years ago about square matrices and how they are very unique. I mean, for starters, they have a determinant and an inverse. Well, most of them do. Some? A good chunk. But let's get right to the example. So this example is telling us to find the determinant of the homogeneous system AX equal to B is consistent, and write the solution in the form of x is equal to xh plus xp if it is. So we are given this system of equation, which is 4 equations, 3 unknowns, and never mind. And the first thing I want to do is break down what x is. So x is just a solution, and this part is the I messed up. It's not the it's a homogeneous. It's a homogeneous. This system is non-homogeneous. Oh my. So it's determinant of the non-homogeneous system. AX is equal to B. Because it's equal to B. It's non-homogeneous. It's homogeneous when it's 0. So this is a homogeneous solution. Plus, this is going to be our particular solution. And so what I mean by like the homogeneous solution, this is basically when AX is not equal, or not plus, is equal to, actually, take that out. AX is equal to 0. And then the particular solution will pretty much be the AX is equal to B portion. And the reason why I can write it like this is because we are working with, or I mean, this is linear algebra. We can write a vector as the sum of 2 other vectors, and we'll know that those 2 other vectors is a solution to the original vector. So in other words, if we have some solution set u of xy, and we know this is like a linear system, then we can make 2 other solutions, which would be u1 xy plus u2 xy, and because these two u1 and u2 equal to u, that means that u1 and u2 are also solutions to a problem, an arbitrary problem that I did not mention. but that's another thing. But we have to first check if this non-homogeneous system is consistent. And so to check if it's consistent, we have to see if the rank of the matrix A is equal to the rank of the augmented matrix AB. So we're going to go ahead and start doing that and writing matrix A in and putting in row reduced echelon form 7, 32, -1, 3, 14, 1, 1, 2. And let me just let that. Okay, so now let's get started. Well, before we get started, we can do a little bit of quick observation. So we have 3 unknowns, we have 4 equations. So that means our rank has to be 3 or less because one of the equations is repetitive. So in other words, one of the equations can be written as a combination of the other 2 equations. So we know for a fact that one of these is going to be a row of zeros. And that's what we're going to find out which one and then see what other ones are rows of zeros. So we're going to get started by adding these 2 together. So we'll have the first 2 staying the same. And then, what is this? 0, 4, 16, 1, 1, 2. And then what I'm going to do is 0 out this -2 and then divide this row by 4. Yeah, 4. And so I'm gonna 0 out this -2 using the first row. So it'll be 1, 3, 10, and then this would be 0, and this would be, I'll multiply by 2, so it'll be 6 plus 7 is 13, and so this would be 20 plus 32 is 52, and then we'll have 0, 1, 4, 1, 1, 2. And so now what I'm going to do is like a triple step. I am going to divide this by 13 because 5 plus, no, not 5 plus 2, 52 is divisible by 13, and subtract or 0 out this 1. So we'll have 1, 3, 10, 0, 1, 4, 0, 1, 4. There's our repetitive equation. And this would be 0, 1 minus 3. 1 minus 3? Yeah. 1 minus 3, -2, and then 2 minus 10 is -8. And so what I also noticed, we have 2 repetitive equations. This row, bottom row, is a multiple of either these 2, and you multiply by -2. So what I'm going to do is now I'm going to 0 out this one and this one. Actually, take that back. I'm going to 0 out the bottom 2. So we are left with 1, 3, 10, 0, 1, 4, 0, 0, 0, 0, 0, 0. And then lastly, getting rid of this 3, and we are left with the row reduced echelon form 1, 0, should be 1, 0, this stays, and this would be -2, 10 minus 12, yes. And we see here our rank is 2, because it has 2 non-zero rows. And now we're going to check the augmented form of this equation. So we're going to start off with the same thing, just going to rewrite everything. Now do a different color. I don't know what to do. Let's try this one. So we're gonna start all over, unfortunately. 1, -2, -1, 1, 3, 7, 3, 1, 10, 32, 14, 2. And this is 18, 29, 12, 8. And so I'm pretty sure you may be asking, is like, yo, why do we have to do the augmented version of A first and then, no, why do we have to do the row reduced echelon form of A first and then do the row reduced echelon of the augmented AB if they might give you the same thing? That might be true, that could happen, but because we have this extra row here, we might get a non-zero term in one of our what we thought was going to be a row zeros. So in this last or in this row reduced echelon form of A, if this was A augmented B, we might have a solution A, B, but then we have a C and then a 0. Then at that point the rank will be 3. So this is why we had to check each one individually instead of just checking the augmented form. So, and not to mention, this will also tell us like how many solutions there will be and if it's consistent. So, I mean, regardless, you did the row reduced echelon form once, and you know what steps you did to make A go to row reduced echelon form. So all you have to do is you do the same thing, and you should be able to get. I'm just gonna write the row reduced echelon form. 1 0 0 4 0 1 0 0 -2 4 0 0, and then I forgot, this would be 0, this would be 0, this would be 3 5, I think that's right. Yeah, so you can go ahead and do this on your own time and check with my my answer. And so we have here that the rank is equal to 2. We know that these two are the same, so that means it is, or we don't know what it is, but AX is equal to B is consistent. Consistent, I think that's how you spell it. And so now we want to find the particular solution, or not the particular solution, the solution. So, to find our solution, we can just rewrite the system of equation with using this. So we'll have x minus 2z is equal to 3, then y plus 4z is equal to 5. You've done this before. That is when you're finding a solution to the system of equation. And so now we gotta find the kernel, so we could just put x is equal to 3 minus 2z, y is equal to 5 minus 4z, and our kernel, and not to mention our kernel is actually our particular solution. And then our homogeneous solution, well, it's just this part. This is our homogeneous solution, HA. And so now we're gonna let t equal to z. So we're gonna have our solution be x, y, z, which is equal to 3, 5, 0 plus, why did I put t? I should have put s. Oh well. -2, +2. You can't do math, sir. +2, -4, not 0, 1. And that is our solution. So actually, let me redo this in what color do I use? Red. So this is equal to 350 plus what was it? T 2 negative 4 1, and that is our answer, or I guess the answer to the second part. So then the first one is that a of x is equal to b is consistent, and so that's how you pretty much do all these problems. And so if it's not consistent, that means there won't really be a solution to this problem. And so that's only true when, if I remember correctly, the rank of a is less than b. The rank of a is less than b. I think that's how it is. I had to double check. But that is all for the Rank-Nullity Theorem and change of bases section. We are now done with this chapter of vector space and subspaces. So honestly, give yourself a pat on the back. You made it this far. And I will say it only gets better, but we're gonna go with a much trickier and a little bit harder concept, which would be, what was it? Linear transformations. Ah, oh, I love those. No, I don't. But I will try my best to explain it to you guys, and then I will also provide other videos from other people to help you give you more of a visual representation and their perspective on how they see it. And for the most part, I think those videos are going to be how you should, like, it will focus more on understanding the concept instead of figuring out how to solve it, because I think if you are able to visually understand the concept, then it will be much more easier to solve the problems. And so it will be up to them, mostly because that's how I learned from linear transformation. So I'll see you guys in the next video.